Hello and welcome to the Computer Vision Festival, hosted by the AI Accelerator Institute, a global community of over 400,000 AI leaders and practitioners, all striving towards one shared goal: inspiring the next generation of machine intelligence. With expert presentations on the festival agenda covering everything from space exploration on Mars to self-supervised learning, you're in for a treat. If you have any questions for our speakers or want to connect with them further, then ask away in the comment sections of the video and hear them answered at the end of each session in our live Q&As. If throughout the day you're loving the content, then be sure to check out the AI membership plans, where you can get access to exclusive content in the form of interviews, reports and articles. Access all areas passes to all past and future events. You can also join our Slack community, which is home to more than 2,500 fellow AI, machine learning and computer vision professionals, and is full of dynamic conversations and contributions. So if you're not already a member, come and join us today. Sign up using the link on the AI Accelerator Institute website. I want to say a massive thank you to all of our sponsors and partners for helping us to bring the festival to your screens today. Our amazing speakers for contributing some awesome content, and to you, our attendees, for joining us today. That's it from us, so go ahead, sit back, relax, and enjoy the festival. Looks like it's pretty much there. Okay, great, let's kick this off. So welcome everyone to the next session of day 2 of the Computer Vision Festival. Really excited about this session. So a big thanks to Jakob for jumping on the agenda. I think it was about 3 weeks ago now, but yeah, the presentation, it looks superb. And Jakob is a product owner of industrial computer vision at Volkswagen Group, and he's here today to speak to you on the scaling of industrial computer vision within Volkswagen Group. And on that note, I'll let you take it away.
Yeah, thanks, Jordan. Thanks for having me. I'm happy to talk about the industrial computer vision technology at Volkswagen. I think we had quite a journey there in the last 1.5 years, and I'm happy to share that with you. And of course, happy to answer your questions afterwards and get new insights, and also happy to discuss your ideas on it. Volkswagen, you probably know, one of the biggest car brands in the world, for sure in Europe, with a lot of major car brands like Audi, Porsche, Skoda, and so on. So really a big industrial company. And today we are talking about applications of computer vision right in the production of cars. So not talking about autonomous driving, stuff like that. So really focusing on the internal processes, how to make that more efficient and more exciting within the production. Agenda, a quick one this time. We have 20 minutes of presentation and then a couple of minutes for a Q&A. But I want to show you through our strategy, where we started off, what took us to where we are today. Talking about the 3 major pillars, so the group-wide use cases we are driving, about the democratization and the IT foundations we're working on, and then finishing with a quick outlook. So industrial computer vision, as I said, focuses on how are we applying computer vision to the production context, a bit or heavily different to the classical end customer applications we know of computer vision. But still not less exciting. When we started off our journey like 1.5 years ago, as per usual, you first start with finding out on what is the starting point, what's the situation in your company. That's exactly what we did. And not surprisingly, we found out that so far, as of 2019, we were really struggling to tap the full potential of computer vision within the production area. Still, on the positive side, we found over 100 and even more use cases that were already pursued across all brands and all locations that we have in Volkswagen. It's probably worth noting we have more than 100 production sites, so the number here is not that surprising, but still very high. So 100 and even more use cases, of which at least 60 were concrete projects with tangible activities. So quite a large number here. But still, most of these use cases never made it really to production. So there were a lot of activities, but none of that was really successful. not even on a local level that you apply a model in one plant, but really a lot of pilots you could see at usually what we heard so far already was the death by piloting or death by POC, and that's what we saw as well. So on the one hand, a very high potential we saw, but on the other hand, still not really earning euros within Volkswagen. That's where we took off, and we started an interview round with all those different project leads we found across the brands. And on the right-hand side, you see the challenges that we identified and also that we assessed for the major impact. And you can see the bigger bubbles on the right-hand side was the impacts, the current pain points that we found. I'm not going to read it out, but I think the major ones were really the missing operations concept, that it's easy to do a pilot, but it's really unclear how to operate a use case sustainably, because in the production context, you cannot fail. There's no tolerance for any misclassification or things like that. So you really need a good operations concept for ICV. The classical IT admin processes were way too complex in Volkswagen because they are designed for classical monolithic applications, but not really for doing agile small projects with a lot of releases. And if you're really forced to do a IT security approval for each of your minor releases, then that's really killing you. Connection to legacy IT, it's honestly one of the biggest challenges we're facing. We have a lot of old legacy systems operating in our plants, and connecting them to state-of-the-art technology is really a pain. External suppliers, a lot of them within Volkswagen, of course, but usually in black box setups where you don't really know what are they doing, what's the quality, what are the transparent costs. There was a major challenge. And last point I want to point out is the IT infrastructure. Usually the local plants did their own pilots in a setup they chose. So the IT infrastructure that the projects used were not really consistent. So potential for scaling wasn't really there at that point of time. That's where we started off. So a lot of challenges, still a very promising technology. And that's where we came off and started with formulating some kind of vision on the right-hand side. That was rather easy since the production in Volkswagen is very cost-focused. So all the use cases we were doing with the technology had to aim for cost reductions. We then said that at least for an aspiration level of double-digit million savings should be in reach for computer vision. And I think we're on a good way to do that. And we also defined in the middle the 3 pillars that we're working on to make that happen. So the first focus is the group-wide use cases that we are identifying and implementing and scaling. So we are really looking for use cases that are huge in saving money, but also probably huge in implementation effort. And that's what we are driving on the central level, where I am most active. Then second pillar is the democratization, where we're thinking about how we can bring computer vision into the plants and really enable plants to make their own pilots on really high speed and see if things work out. And then the third pillar, the IT foundations, but not only IT, but also organizational foundations, to make sure that all the use cases we're implementing are on the same page and have the same top-notch prerequisites to be successful. And I'm going to talk you through all 3 of these pillars in the next sections. So coming to the group-wide use cases, as I said, there we had the luxury problem of that there are so many ongoing use cases, projects, and ideas across the company that we really were struggling to identify, okay, which of these are really the euro earning, the really profitable applications that we need to go after. Because a classical situation that you will face in any big company is that there's a lot of pilots, but no one really thought about what's the business case behind. Does it make sense? Is that really the most profitable application that we're pursuing, and not only the first best that we found? So something we started off with is that we took a couple of production sites, and you can see it on the left-hand side. We really walked through the whole production site and talked to all the employees on site, and really identified a long list of ideas what within that production site could be feasible and attractive applications for computer vision. I'm not lying if I tell you that per each location, there's easily like 50 use cases you identify. So it's super important on the right-hand side that you go into prioritization. That took a lot of time, to be honest, because usually the production workers are not really used to the technology and how to assess how many euros are behind each application. So that's something that took quite some time, and most of that 50 applications are not don't have a positive business case. So you usually end up with like 2, 3, 4 applications that are really profitable, and that was the basis that we worked right. So we looked at a couple of production sites, and then we had a look at what are the use cases that are coming again and again, where we can be sure, okay, that's scalable use cases, and that's what we focused on and started off with. And in 2021, I brought a couple of examples that we are working on currently, rolling out across our different brands. On the left-hand side, type label inspection. You might know there's a type label in each car, the little black label you can see in the photo. And per each country, it's very different where you put those labels, what you write on it. Sometimes the workers put it on with some kind of damage on it. So there's a lot of things that can go wrong. And if you export your cars, then in customs, you will have big troubles if your type labels are not correct. And you can imagine if you have a German plant and then there's a Chinese type label in it, the German worker will have huge problems to check if that's the right type label in Chinese. So computer vision is a really nice technology here to implement this. And I'll tell you on the next slide, this is the first use case that we also brought live into production. So one of our major flagship use cases. On the middle, that's a very nice use case with a crack detection in the press shops. In Volkswagen, on large scale, we are pressing metal parts, and every, I don't know, a couple of thousand parts, there might be cracks in it. And of course, you need to identify this, because if you have a cracked metal part and you install it into some kind of car, then you could end up with crashing your whole car in the end, because it would be too expensive to reinstall everything and then bringing in a new piece again. So crack detection is a very key use case for us, and traditional computer vision didn't really work out here because you had too many false positives and false negatives. And with computer vision, we found out the precision and recall is much nicer than with a classical computer vision. So a really great use case here, especially regarding that Volkswagen has so many press shops and there's really nice data available on this. And then third and rather straightforward use case, again, assembly checking here with underbody of cars, where a new legislation in Europe forces us to check all the parts that we assemble on the underbody of the car. And that's what we are doing now with the camera. We are segmenting the underbody of the car and then checking against the production IT systems. Are the parts that we are detecting on the car, are these the ones that we would expect? And again, a nice use case, saving us manual visual inspections and increasing our legal compliance there. And as I said, one of those use cases already in production, the type label checking that I was talking about earlier. You can see here on the left-hand side, it's a bit small, but you can see the camera that's on that metal thingy in the middle. So that camera is a fixed installed camera, and whenever there's a car crossing by, there's a trigger signal by the production IT system, and we're taking a photo of the type label. And then in the cloud, we are checking, is the label on the right position? Is it existing? Does it have damages? Is the content right? And so on. So that was a major success of ours, that this is now working. We're still working on stabilizing it, since we're working with a very new setup with cloud involved here. But still, in general, it's working fine. And we are very positive that this is a use case we can roll out across a lot of areas. That was on the use cases, as I said, the ones that are group-wide relevant, that have high scalability. Apart from that, we are talking about democratization. And democratization for us in computer vision means that we are talking about the smaller projects mainly. On the upper part here, I showed the use case pipeline and the way we are thinking about it. So 4 major steps here that are probably not surprising in an agile setup. First, you are generating and assessing ideas, then you're piloting them. And if the pilot is successful and there's a lot of potential behind it, you implement the use case, bring it into series. And then if that's successful and other plants have demand for that use case, you can scale it across brands. And as I said in the beginning, we are focusing on scaling, of course. So we are heavily relying on that use case is working nicely and that we have enough pilots and enough use cases going on in the different plants that we can take and then scale across groups, across the plants. And what we found out is that with our central approach, that we take major use cases and develop them together with our let's say, relatively costly VW developers. And that's not an approach to develop all those smaller use cases we have across the brands. That's why we were thinking about how can we bring the technology into the plant so that everyone can work on their own projects and see what the local problems are, and then just test if computer vision can solve them. So that's the idea behind the democratization. And on the lower part of the slide, you see what we are exactly working on. So for us, the democratization has 2 aspects. On the right-hand side, of course, the technical aspect, you somehow need to enable the plants to do their own CV models, to develop them on their own. But then at the end, if the model works, you need some kind of feedback into the system. And for us, the PLC is the main computer setup that we're working with in a production context. That's why we are working on some kind of very simple self-service PLC interface, so that once you have a nicely working CV model and you detect the defects you want to see, or you detect the objects you want to check, that you have an easy interface back into the PLC where you can tell the system, okay, there's an error, stop the production, or you can say, that's all right, continue. So that's the straightforward technical aspect. But on the left-hand side, in a very complex group like Volkswagen, the organizational setups are also a major challenge, as I mentioned earlier. So you need to find a lean way on how to deal with IT security, how to deal with all the kind of open source approvals you need to have within Volkswagen. So there's a lot of hurdles that our IT admin processes are defining. And if you want to do lean small pilots in the plants, of course, you need to make that handle, to make it easy for the plants to handle that kind of complexity. And honestly, the left-hand side, the organizational part, is for us more of a pain than the right-hand side, to find lean ways on how to do computer vision on local level as well. But so far, that's working really nicely. I'm going to talk about our computer vision platform that we're using in Volkswagen a little later. But so far, we really managed to make it as easy as possible. We have a nice developer guide for new joiners, how to set up our platform and how to connect cameras and so on. And so far, results are really, really promising. And we are super looking forward to having hopefully dozens, if not hundreds, of local pilots in our plants by next year. All right, and then last content would be the foundations. I just mentioned it. We have our own IT infrastructure that we set up for computer vision. Of course, you're aware there's a lot of external suppliers where you can buy computer vision platforms and startups that have easy to use products. But nevertheless, we found that these do not really fit our specific requirements as a very complex car producer. So that's why we ended up with defining our own platform, which we are calling Vision Workbench. And we're using a lot of open source software there. So the platform can handle most of the classic computer vision use cases like object detection, classification, segmentation, and so on. So stuff that's rather familiar, but still which covers like easily 95% of all the use cases that we found in our plans. So that's from technical use case level, that's I think a very nice starting point. More exciting is the feature list on the right-hand side, which defines why our own platform is better for us than any external buy software you can get on the market, because we are really pursuing an end-to-end approach from Volkswagen perspective. starting from a very easy camera integration where we cover most of the standard drivers you have for all kind of camera brands. So since we have a lot of different cameras working in our systems as of today, we need to cover all those different cameras so that the plants can continue to use their own camera technology that they have as of today. I think our camera driver is now very nicely easy click and connect approachy. And the second point is actually the key thing that was our main challenge. So we have a lot of standard interfaces now to our standard production IT systems. As I said, most of those production IT systems are quite old, so it's not that straightforward to have a working interface to these. And the magic behind here is now that the more use cases we have developed on the platform, the more of these interfaces are already existing. So we will really increase speed by every use case because by some point of time, hopefully end of this year, we will have connected all the major IT systems, and then it's really simple for everyone to build new computer vision use cases. Deployment is a major challenge for us. Of course, I'll show you on the next slide. We are working with cloud as a first best solution, but nevertheless, due to latency challenges or cloud cost consumption aspects, we also offer edge deployment or data center deployment options because our production sites still like to have full control over their own technology. So they are still a bit hesitant to put critical infrastructure into the cloud. So it's often easier to start with some kind of data center deployment, and then if that works out nicely, then you can move to the cloud later. But it's a nice door opener if you can offer the local deployment as well. And then, of course, we cover everything from model training until operations. And very important in Germany and in Europe in general, we have an anonymization tool in the platform because the data protection aspects in Europe are quite severe, and you need to have good answers. If a workers' council or employees are asking you, why are you putting cameras here and what are you doing with it? Then you better have the answer that now we are anonymizing and there's no personal data, and in the data we are saving. That's a major door opener here. And on the left-hand side, the team, we decided to go with internal resources as a start. Since, as I said, we're working with open source software mainly, it's more about cleverly putting together everything that's there on the market. And now we have like a team of, I would say, like 10 people who are working on computer vision on full time. So both on the platform level, but also on use case level. And with that team, the major advantage here is that we have a sustainable integration. So it's not an external provider that we're buying, and by the time that external provider's leaving, we don't have any clue anymore what's going on, but we still have full control about what we're doing. And once the scaling really kicked off with our computer vision use cases, then probably we will onboard more externals as well here. So much of focus on internal things here with the computer vision technology. I talked about cloud a lot. I want to show you one slide here, which is quite a nice piece of technology, I find. A couple of years ago, Volkswagen partnered up together with AWS to build the so-called industrial cloud, which is mainly a standard AWS cloud, but really tailored to the needs of production and industry needs. And by now, many of our Volkswagen plants are already connected to that cloud, which makes it really a game changer for us in computer vision. Because if you look at the use cases that I talked about earlier, if you really want to scale those, you need some kind of foundation, how to gather data centrally, train your models, and then deploy your models, even if you have a local deployment. And the industrial cloud is our major vehicle for this. And together with Siemens, I haven't mentioned them yet. As I said, we have a very nice cloud that is tailored to our needs here. And as a next step, once we have started scaling within Volkswagen Group, we're also planning to have a public marketplace on that, so that use cases as the crack detection that I mentioned earlier are available publicly. And we are really hoping that this is also a nice extra additional revenue we can generate in the next couple of years after scaling at Volkswagen was successful. All right, and then just a quick outlook, mainly summing up what I already told you a couple of times now. With our ICV strategy, we started in 2019 with the road that I showed you in the beginning. We defined our strategy in 2019, made things ready for starting. Then in 2020, we focused on building the platform, not only the technical platform, but also the organizational platform. This year, we really are starting to ramp up the technology. I showed you the first use cases we are working on. There's a lot more that we are currently working on, and we are starting scaling. And then the major goal is that by next year, we are really talking about industrializing ICV so that we have many more use cases and many more plans, and that rollouts are really fast and simple, and via the industrial cloud, hopefully also externally available. And that's it already that I wanted to show you. Thank you for your patience, and now I'm happy to take your questions.
Hey there, Jakob. So so just us. Okay, yeah, great presentation. Thanks so much for putting that together. Really enjoyed that. So yeah, now we can open it up for a little bit of Q&A. We've got a couple of questions already in the chat, but as Jakob is answering the questions, do feel free to post one, and we've got a little bit of time left. So first question comes in from Ben. So how many people are in your CV development team, and how long does it normally take to move between generating an idea and hitting scale?
As I said, it's like 10 developers that are working full-time on the platform and the use cases. There's a lot more project managers, because, as I said, the organizational processes around use cases are quite intense. But like, I would say 10 developers. Between generating an idea and hitting scale, I can't tell you so far, because, as I said, we just started scaling. So for our first use case, the type label checking that I showed you, it was like 1.5 years, but really we had to solve a lot of homeworks on that first use case. So I'm pretty sure that we can do it in like 6 months for the next use cases next year.
Okay, nice. Yeah, good to hear. So on to the next question. Are cameras equipped with hardware? Are cameras equipped with hardware which can handle the use case, or cameras send the recording to main processor where all use cases are carried out?
Yeah. No, we are connecting computers to our servers, and then depending on where we deployed our model, it's running in the cloud usually. So real edge applications, I haven't seen any, I think, so far.
Okay, understood. And which is the main use case? Which is the main use case, and which one is the most challenging one?
Yeah, I'm probably not allowed to tell you, but I can tell you that the probably a very profitable one is the crash detection, because, as I said, it's a very generic use case, and the scale is huge there. Volkswagen is producing like 11 million cars every year, and you can imagine how many pressed parts we are using for each car. So that's an enormous scale. More challenging is probably the assembly checking that I showed you, because there we are struggling a bit with different local situations in each plant. Per car type, it's then different on what you want to check, what are the lighting conditions around it. Often you need a robot to bring the camera on what you want to check. So let's say the computer vision model is not that much of a challenge, but organizing everything that it really brings value for Volkswagen, that's a major challenge here.
Okay, great. So I hope that answers your question there. So if no one's got any more questions for Jakob, we've still got a couple of more minutes, so do feel free to post them. But yeah, if there's no more questions, just like to give you a big thank you, Jakob. You'll also be presenting tomorrow morning in one of our panels. Just got a question in there from Bing Wang. So do you know how many customers currently use the AWS Industrial Cloud?
That's a good one. I think you can check that online, but I think there's like 30 companies on it right now. But it's, as I said, still in a very early phase. So I'm pretty sure by next year, at least for computer vision, we will really scale, and there's hopefully 100 and much more.
Hopefully. Okay, cool. And then another question in from Shiva. So in label tasks you mentioned, are you applying text recognition? If yes, convolutional networks or generative?
Text recognition, we tried a couple of things there to build our own and use standard stuff. As I said, we tried to do things agnostically. So actually we didn't plan to use many of the AWS services, but we ended up that the AWS text recognition is just a very easy to use and simple service. So that's one of the services we're definitely using, and it didn't really make much sense to build something on our own.
Okay, got it. So as I was mentioning, Jakob will be on another presentation tomorrow. It's actually a panel. It's called Industrial Innovations. So look out for that one. It starts at 3 p.m. UK time, 7 a.m. West Coast, 10 a.m. Eastern, I believe. But thank you so much, Jakob. It's been a pleasure, coordinating with you this time, or this whole time. One more question, why not? We still got another couple of minutes. So how close are you to launching an FSD vehicle?
What's FSD? Help me out.
So if you could just elaborate on that question, we can get to it.
Is that autonomous driving?
I was assuming it was, but I don't know that abbreviation. I'm assuming it is.
As I said, I'm not really into autonomous driving because the challenge, of course, autonomous driving. That's not really my domain since I'm focusing on production. But I think by end of 2023 or 4, I think we're planning to have our first, at least for commercial applications, our first autonomous car.
We hold you to that, Jakob.
As you might have heard, Tesla is now focusing only on computer vision technology for autonomous driving. So that's quite a major step here, because all the other car producers are using LiDAR and radar and stuff like that. So that would be an interesting development if Tesla can really make it only with camera technology. But honestly, I'm not an expert here. I can just tell you what's on the public information anyways.
Okay, cool. But once again, a big thank you to the audience for tuning in. Really enjoyed that presentation. As usual, I'll post a link to the next session in this chat. It's been a pleasure working with you, Jakob.
Yeah, thank you for having me.
Okay, cool.
And see you tomorrow.
Cool. Take care. See you later. Bye-bye.
Bye.